42 On the morning of March 14, 1941, Beatrice Schilling stood on the tarmac at RAF Kenley, watching a Hurricane pilot climb into his cockpit for what could be his final sortie. She was 32 years old, had spent 6 years at the Royal Aircraft Establishment, and so far had produced 0 accepted fixes for the problem that was killing her pilots. That week, the Luftwaffe had sent 43 Messerschmitt Bf 109 fighters across the channel. RAF pilots had met them in 27 separate aerial engagements. 14 Hurricanes had been lost. 9 Spitfires. The pattern never changed. A British pilot spotted a German fighter and pushed into a dive to attack. The engine cut out. The German aircraft escaped, or worse, looped back and riddled the helpless Hurricane with gunfire while the pilot fought desperately to restart his Rolls-Royce Merlin engine. Schilling had studied the combat reports, pored over the maintenance records, and interviewed pilots who survived the failures. The carburetor flooded during negative G maneuvers. Simple physics, lethal consequences. When a Spitfire or Hurricane entered a sudden dive, fuel surged to the top of the float chamber. The jet starved. The engine died for roughly 1.5 seconds. 1.5 seconds was enough time for a Messerschmitt to close 300 yards and fire. The Germans did not suffer this flaw. Their Daimler-Benz engines used direct fuel injection, no float chamber, no flooding. Bf 109 pilots could dive, climb, roll, and fly inverted without losing power for even an instant. It gave them a decisive edge in every fight. British pilots understood it. German pilots exploited it. Squadron commanders reported it. And the Royal Air Force was losing experienced airmen faster than training schools could replace them. Schilling had spent 11 months attacking the problem. Engineering teams at Rolls-Royce were developing a pressure carburetor, a proper solution, a complete redesign of the fuel system, but it would not be ready until 1943, perhaps 1944. The war would not wait. The pilots could not wait. Every morning, young men climbed into Spitfires and Hurricanes knowing their own engines might kill them before the enemy could. Squadron leader Davies walked past Schilling toward his Hurricane. He was 24 years old, had flown 41 combat missions, and had 3 confirmed victories. He had reported engine failure twice in the past month, both during combat dives, surviving only through luck and thousands of hours of training. He nodded at Schilling. She nodded back. He did not know she was the carburetor specialist from Farnborough. He likely assumed she was a secretary. If you want to see how Schilling's breakthrough saved RAF pilots, please hit the like button. It helps us share more forgotten wartime stories. Subscribe if you haven't already. Back to Schilling. She had brought something with her to Kenley that morning, a small brass component, precisely machined and deceptively simple. Her team at the Royal Aircraft Establishment had tested it on a bench engine for 6 weeks. It worked, but bench tests were not combat. Combat meant 300 miles per hour. Combat meant negative G-forces strong enough to pin a pilot into his harness. Combat meant life or death decided in 1.5 seconds. Schilling walked to her Norton motorcycle. Inside her leather satchel was the brass restrictor and a plan that would either save the Royal Air Force or end her career at Farnborough. By noon, she would know which. The carburetor problem had begun in July 1940, when the RAF switched to 100-octane fuel. Higher octane allowed more boost. More boost produced 1,310 horsepower from the Merlin instead of 1,100. The Spitfire Mk2 could now reach 370 miles per hour in level flight, fast enough to catch Messerschmitt 109s, but the Skinner's Union carburetor could not tolerate the negative G-forces that accompanied high-speed combat maneuvering. Schilling understood carburetors better than anyone at Farnborough. She joined the Royal Aircraft Establishment in November 1939, 1 month after war was declared. She was one of only 2 women in the engine department. The other was a secretary. Schilling was the principal technical officer responsible for carburetor research and development. Most of the men she worked with had never encountered a female engineer, and some doubted women belonged in engineering at all. Schilling was indifferent to their opinions. Her concern was keeping pilots alive. She had grown up dismantling engines. At 14, she bought her first motorcycle, a Norton, and stripped its 2-stroke engine down to individual components, learning how each part functioned before rebuilding it. At 25, she raced that same Norton at Brooklands at an average speed of 106 miles per hour, fast enough to earn the British Motorcycle Racing Club Gold Star. Only 3 women in history had achieved that distinction. Schilling was the second. Racing taught her how engines failed under stress, high G-turns, abrupt acceleration, extreme lean angles. She learned to sense what an engine required before the instruments revealed it. That intuition made her the finest carburetor specialist in Britain. And now British pilots were dying because their carburetors could not withstand combat stresses. The solution came to her in January. Again, it was simple physics. The float chamber flooded because fuel could flow unrestricted when gravity reversed. What if the flow were restricted, not stopped entirely, just limited enough to prevent flooding? The engine would still receive fuel, just not too much. A brass disc with a precisely calculated hole in the center, installed in the fuel line ahead of the carburetor, limiting maximum fuel flow to slightly below what the engine demanded at full throttle. Schilling machined the first restrictor herself, a brass thimble shape, 0.125 inches in diameter, with a central hole measuring 0.040 inches. The dimensions were critical. Too large and flooding would continue. Too small and the engine would starve at full power. She tested 17 different sizes before finding the correct one. Then she simplified the design. A flat washer was easier to manufacture, easier to install, and easier to replace if damaged. Bench tests confirmed it worked, preventing flooding during simulated negative G conditions. But bench tests were not combat. She needed to test it in an actual aircraft under real combat conditions. The obstacle was permission. Installing unauthorized modifications on RAF fighters violated roughly 40 regulations. If the restrictor failed and a pilot died, Schilling could be court-martialed or imprisoned. She chose to bypass permission and ask forgiveness later. That morning at Kenley, she carried 6 restrictors in her satchel and relied on one cooperative ground crew sergeant who owed her a favor. Sergeant William Cooper had worked on Merlin engines for 3 years and had seen 19 pilots die from engine failures. He asked no questions when Schilling showed him the brass washer. He simply nodded and reached for his tools. The Hurricane sat on the dispersal pad, pilot inside, engine warming up, 20 minutes to take off. Cooper worked quickly. He disconnected the fuel line between the pump and the carburetor. The restrictor slid into place. He welded it with a small butane torch. 60 seconds of work. The modification was invisible unless you knew where to look. Schilling inspected the weld clean, solid, professional. Squadron leader Davies would fly with the restrictor installed. He did not know it was there. Schilling had not told him, had not told the squadron commander, had not told anyone except Cooper. If the restrictor failed and Davies died, there would be no paper trail, no authorization forms, no testing. Documentation. Just a dead pilot and a brass washer that shouldn't have been there. The Hurricane's Merlin engine roared to full power. Davies ran through pre-flight checks. Oil pressure good, coolant, temperature good, magnetos firing on all 12 cylinders. He released the brakes. The Hurricane rolled forward, gathered speed, lifted off. Schilling watched it climb. 800 feet, 1,200 feet, 2,000 feet. The Hurricane banked south toward the channel. She'd brought a pair of binoculars. She watched Davies climb to 15,000 feet. 2 more Hurricanes joined him, a section of 3, standard patrol formation. They flew toward Dungeness. German fighters had been active over Dungeness all week. If Davies encountered a measurement, he'd have to dive and the restrictor would either work or it wouldn't. Schilling waited on the tarmac. Cooper stood next to her. Neither of them spoke. Ground crew prepared 2 more Hurricanes for the afternoon patrol. A fuel truck rumbled past. Mechanics shouted technical jargon across the dispersal area. Normal sounds of a fighter station at war. Schilling heard none of it. She was calculating fuel flow rates in her head. 4 inches. Maximum flow at full throttle. Negative G duration 1.5 seconds. The math worked, but math wasn't combat. 40 minutes passed. An hour. Radio silence from Davies's section. That could mean anything. No contact with enemy fighters. Or contact so intense there was no time to report or Davies was dead and his Hurricane was scattered across a French field. At 0937 the radio crackled controller's voice. 3 Hurricanes. Inbound 2 minutes out. Schilling raised the binoculars. She saw them. 3 dark shapes against the morning sky. All 3 aircraft. No losses. The Hurricanes entered the circuit. Davies landed first. He taxied to dispersal. Cut the engine, climbed out. Schilling walked toward him. Her hands were shaking. She'd designed bombs before. She tested engine modifications under laboratory conditions. She'd never done anything like this. Never installed an unauthorized modification and sent a pilot into combat to test it. Davies pulled off his helmet. He was smiling. That was unusual. Pilots didn't smile after combat patrols. They usually looked exhausted, haunted. Davies looked excited. Cooper asked the question. Any problems with the engine, sir? Davies looked at Cooper, then at Schilling, then back at Cooper. Best the Merlins ever run, he said. Dove on 2 messers over Dungeness. Engine never missed a beat. Schilling asked Davies to describe exactly what happened. He'd spotted 2 messers 109s at 14,000 feet, both aircraft flying east toward France. Davies had positioned his section above them. Altitude advantage. He'd pushed into a steep dive, 400 miles per hour. Negative G forces strong enough to lift him against his Harness straps, the dive that should have killed his engine, but the Merlin kept running. Full power through the entire dive. Davies had closed to 200 yards before the German pilot saw him. He'd fired a 3-second burst, saw strikes on the left Messerschmitt's wing route. The German fighter broke hard right and fled toward France. Davies had pulled up, climbed back to altitude. The engine had performed flawlessly. It was the first time in 11 months that Davies had successfully pressed a diving attack without his engine cutting out. He wanted to know what maintenance had done to his Hurricane. Schilling told him. She explained the restrictor, the brass washer, the fuel flow limitation. Davies stared at her for 5 seconds. Then he turned to Cooper. "Put that thing in every Hurricane on this station," he said. "Today." Schilling explained it wasn't authorized. Davies didn't care about authorization, he cared about surviving combat. Every pilot at Kinley had lost friends to engine failures. 19 pilots dead in 6 months. Davies said if the brass wanted to court-martial him for installing an unauthorized modification, they could do it after the war. Right now, his squadron needed working engines. Cooper installed restrictors in 4 more Hurricanes that afternoon. Schilling had brought 6. She kept 1 for testing. 5 Hurricanes flew combat patrols with restrictors over the next 3 days. 0 engine failures, 12 diving attacks successfully pressed against German fighters. Pilots reported the Merlin engines ran perfectly, better than perfectly. Some pilots claimed they were getting more power at altitude. Word spread fast. By March 18, every squadron commander in 11 Group knew about the restrictor. They wanted it, all of them. Immediately, Schilling received 14 phone calls in 2 days. Could she come to their stations? Could she bring more restrictors? How fast could they be manufactured? The problem was supply. Schilling had machined 6 restrictors herself in the RAE workshop. Manufacturing thousands would require proper production facilities, brass stock, precision machining equipment, quality control. She needed approval from the Air Ministry. She needed funding. She needed time. She got approval in 4 days. The Air Ministry fast-tracked her proposal. A war-winning modification, they called it. Rolls-Royce received the production contract. They could manufacture 500 restrictors per week. Installation would begin immediately at every fighter station in Britain. Schilling assembled a small team, 3 engineers from Farnborough, 2 civilian mechanics. They would tour RAF stations and oversee installation. The restrictor could be fitted without removing aircraft from service. That was critical. Every Hurricane and Spitfire needed to stay operational. The Battle of Britain was technically over, but German fighters still crossed the Channel daily. RAF Fighter Command couldn't afford to ground its squadrons. Schilling loaded her Norton motorcycle with tools and restrictors. She'd visited 43 RAF stations before the war. She knew every fighter base in southern England. She knew the commanding officers. She knew the ground crews. Now she'd visit them again, this time with a brass washer that would save their pilots. By March 25, installation teams were ready. 600 restrictors manufactured, 40 stations on the schedule, 3,000 Merlin engines waiting for modification. Schilling started her Norton and headed north toward Biggin Hill. Biggin Hill was the busiest fighter station in 11 Group. 32 Spitfires, 21 Hurricanes, 4 squadrons rotating through continuous combat operations. Schilling arrived at 0800 on March 26. Station Commander Group Captain Grace met her at the gate. He'd lost 7 pilots to engine failures in the past 2 months. He wanted the restrictors installed immediately. The ground crews worked in shifts, 4 aircraft at a time. Each installation took 12 minutes. Disconnect fuel line, weld restrictor in place, reconnect line, test for leaks. The welding had to be perfect. A faulty weld at altitude could starve the engine completely. Schilling supervised every installation personally. She checked every weld, tested every connection, rejected 3 restrictors that didn't meet specifications. Pilots watched the modifications with intense interest. Flight Lieutenant James Lacey had 41 combat missions. He'd experienced engine failure twice, both times during critical moments in dogfights. He asked Schilling how a simple washer could solve the complex carburetor problem. She explained fuel flow physics, float chamber dynamics, negative G effects on liquid fuel. Lacey understood immediately. He was an engineering graduate from Cambridge. He called it brilliant simplicity. By March 28, all 53 Merlin engines at Biggin Hill had restrictors installed. Schilling moved to Hornchurch, then Northweald, then Tangnere. The pattern repeated at every station. Ground crews worked 12-hour shifts. Pilots flew combat patrols with modified engines. 0 failures reported. The restrictor worked exactly as designed. Pilots started calling it Miss Schilling's Orifice. The nickname came from Sir Stanley Hooker, chief engineer at Rolls-Royce Supercharger Division. It was crude British humor, slightly inappropriate. Schilling didn't mind. She'd spent 6 years working with RAF personnel. She understood how military men dealt with stress. If crude nicknames helped them remember the modification, she'd accept any name they wanted to use. The nickname spread faster than the restrictor itself. By April, every pilot and fighter command knew about Miss Schilling's Orifice. They requested it. Specifically, some pilots refused to fly combat missions until their aircraft had the modification installed. Squadron commanders supported them. They'd seen too many good pilots die from preventable engine failures. German intelligence noticed the change in British fighter performance. Luftwaffe after-action reports from early April mentioned improved RAF diving attacks. British fighters no longer broke off pursuit during negative G maneuvers. Meshmid pilots could no longer exploit the carburetor weakness. The tactical advantage had disappeared. By mid-April, Schilling's team had installed restrictors in 2,100 Merlin engines, every Hurricane and Spitfire in fighter command, every operational training unit, every aircraft in reserve status. The modification became standard equipment. New aircraft rolling off production lines at Castle Bromwich and Southampton came with restrictors pre-installed. The pressure carburetor was still in development. Rolls-Royce estimated it would be ready for production in 1943, but the restrictor worked so well that some engineers questioned whether the pressure carburetor was even necessary. Why redesign the entire fuel system when a 50C brass washer solved the problem? Schilling knew the answer. The restrictor was a stopgap, a brilliant stopgap, but temporary. The pressure carburetor would eliminate the negative G problem completely. No fuel flow restrictions, no power limitations, full engine performance under any flight condition. That was the proper engineering solution. But until 1943, Miss Schilling's Orifice kept RAF pilots alive, and that was enough. The results were measurable. Fighter command tracked combat statistics meticulously. Every engagement, every kill, every loss, the numbers told a clear story. March 1941, before the restrictor, RAF fighters reported engine failures in 38% of diving attacks against German aircraft. Pilots broke off pursuit. Enemy fighters escaped. Or worse, German pilots recognized the weakness and exploited it. They deliberately lure British fighters into diving attacks, knowing the Merlin engines would fail. April 1941, after the restrictor, engine failures during diving attacks dropped to 0.4%. Almost non-existent. The few failures that did occur were unrelated to the carburetor. Mechanical problems, battle damage, normal combat attrition. The kill-to-loss ratio improved immediately. March had been brutal. Fighter command lost 47 Hurricanes and Spitfires in combat. Shot down 61 German aircraft, a ratio of 1.3 to 1, barely breaking even. April was different. 29 British fighters lost. 94 German aircraft destroyed, a ratio of 3.2 to 1. The restrictor wasn't the only factor, but squadron commanders credited it as a major contributor. Pilots reported increased confidence in combat. Flight Lieutenant Robert Stanford Tuck flew Spitfires out of Duxford. He'd experienced engine failure for times before the restrictor. After installation, he pressed diving attacks without hesitation. He destroyed 3 Messrs 109s in May, 2 more in June. He credited the restrictor with giving him the confidence to commit to aggressive tactics. The modification Spread beyond Fighter Command. RAF Coastal Command requested restrictors for their BAW fighters. Bomber Command wanted them for training aircraft. Even the Fleet Air Arm inquired about installation on carrier-based fighters. Schilling coordinated production with Rolls-Royce. By June, they were manufacturing 1,000 restrictors per week. The restrictor remained in service through 1943. Rolls-Royce finally introduced the pressure carburetor in January 1943. The new carburetor eliminated the negative G problem completely. It used fuel injection principles similar to German engines. No float chamber, no flooding, perfect fuel delivery under any flight condition. But converting existing aircraft to pressure carburetors required extensive modifications. Remove the old carburetor, install new fuel pumps, rewire engine controls. Each conversion took 8 hours. During those 8 hours, the aircraft couldn't fly combat missions. Fighter Command couldn't afford to ground squadrons for extended maintenance, so they kept the restrictors. Many aircraft flew with Miss Schilling's orifice until 1944. Some until the end of the war. New production Spitfires and Hurricanes received pressure carburetors, but older aircraft kept their restrictors. Pilots trusted them. Ground crews knew how to maintain them. If it worked, don't change it. Schilling moved on to other projects. She worked on cold weather starting systems for engines in Iceland and Russia. She researched high-altitude fuel mixture problems. She helped design improved supercharger systems for late war Merlin variants. The Royal Aircraft Establishment kept her busy with dozens of technical challenges, but the restrictor remained her most famous contribution. Pilots remembered it. Engineers studied it. After the war, aviation schools taught it as an example of elegant problem solving under pressure. Simple solution, immediate implementation, measurable results. Everything good engineering should be. Keith Maddock, chief engineer at Hangar 42 during the war, said it years later. Beatrix Schilling helped us win World War II. Of that, there is no doubt. The restrictor was a war-winning modification. Schilling's work didn't stop with the restrictor. The Royal Aircraft Establishment had dozens of critical problems that needed solutions. Engine failures at high altitude, fuel system icing in extreme cold, starting problems in Arctic conditions. Every problem threatened pilot lives. Every problem landed on Schilling's desk. She worked on cold weather modifications for Spitfires deployed to Murman. Russian winter temperatures dropped to -40 degrees Fahrenheit. Standard engine oil turned to sludge. Batteries died, fuel lines froze. British pilots couldn't start their aircraft, and Soviet ground crews had no experience with Merlin engines. Schilling developed a cold start procedure using preheated oil and modified fuel mixtures. It worked. Spitfires flew combat missions over Germany throughout the winter of 1941. She researched high-altitude performance problems. Late-war Spitfire variants operated at 35,000 feet, where the Merlin engine struggled. Thin air, low oxygen content, and fuel mixtures had to be precisely calibrated. Too rich, and the engine flooded. Too lean, and it overheated. Schilling developed altitude-compensating carburetor modifications that improved power output by 8% above 30,000 feet. Her personal life remained separate from her work. She had married George Naylor in September 1938. He worked at the Royal Aircraft Establishment as an aerodynamicist, and when the war began, he volunteered for RAF Bomber Command. He flew Avro Lancasters with 625 Squadron, completing 31 combat missions over Germany, earning the Distinguished Flying Cross for undertaking an extra tour beyond his required missions. Schilling worried about him every time he flew, understanding the high bomber loss rates. 1 in 2 crew members didn't survive the war. Naylor beat the odds and returned to Farnborough in 1944. They never discussed his missions, and he never asked about her projects. They kept work and marriage in separate compartments. Schilling continued racing motorcycles when possible. Though she had stopped racing at Brooklands when the war started, its circuit converted to aircraft production, she still rode her Norton. High-speed riding helped her think and solve problems that laboratory work couldn't. Some of her best engineering ideas came while riding at 90 miles per hour on country roads. By 1945, she had worked on 17 major projects at Farnborough: cold weather systems, high-altitude modifications, carburetor improvements, fuel mixture optimization, supercharger efficiency upgrades. Each project saved lives and kept RAF aircraft operational under extreme conditions, but none achieved the fame of the restrictor. The war ended in May 1945 with Germany's surrender, followed by Japan in August. The Royal Aircraft Establishment transitioned from wartime emergency projects to peacetime research, with a slower pace, lower urgency, and different priorities. Schilling stayed at Farnborough, intent on continuing her engineering work. In 1948, she received official recognition for her wartime contributions when King George VI appointed her Officer of the Order of the British Empire. The OBE ceremony at Buckingham Palace saw Schilling wear formal dress, accept the medal, pose for photographs, and return to work at Farnborough the next morning. She never stopped engineering, solving problems, or proving that women belonged in technical fields. Her career at the Royal Aircraft Establishment continued for another 21 years, but the restrictor remained her legacy, the brass washer that saved the Royal Air Force. Schilling worked at the Royal Aircraft Establishment until 1969, completing 33 years of continuous service. She never reached the top administrative positions, reserved for men, but she accepted this limitation, preferring hands-on engineering work, laboratory testing, field modifications, real problems with real solutions. Her post-war projects included the Blue Streak missile program, Britain's first ballistic missile, where she worked on fuel delivery systems and high-altitude performance. She researched wet runway braking effects for jet aircraft, as landing accidents killed more pilots than engine failures by the 1950s. Understanding water's effect on runway friction could save lives. She published 3 technical papers on the subject and even helped design a bobsled for the Royal Air Force Olympic team, a strange project for an aeronautical engineer, but it involved aerodynamics, weight distribution, and friction management, all skills Schilling had mastered. The RAF team used her bobsled design in competition. They didn't win medals, but they didn't crash either. Schilling retired in 1969 at age 60, restoring vintage motorcycles, racing occasionally at classic motorcycle events, and maintaining her Norton, the same machine she'd raced since 1934 that had taught her how engines behaved under extreme stress. She died on November 18, 1990, at age 81, survived by her husband George and a lifetime of engineering achievements. British obituaries focused on the restrictor, the brass washer, her simple but revolutionary design. Everything else she accomplished was footnotes. Her legacy lived on in unexpected ways. In 2011, a pub in Farnborough was renamed the Tilly Schilling. In 2015, Brooklands Museum purchased her racing trophies and badges. In 2018, Winchester Heritage celebrated her as one of Hampshire's extraordinary women. In 2019, Royal Holloway University opened the Beatrice Schilling Building for Electronic Engineering, and on March 8, 2019, the mayor of Waterville unveiled a plaque at the local library, 110 years after her birth. The restrictor itself became a teaching example, studied worldwide in engineering schools as a simple solution to a complex problem, immediately implemented under wartime pressure with measurable, life-saving results. Some universities even display original restrictors in museum cases, small brass washers reminding students that elegant solutions don't require complexity. If this story moved you as it moved us, hit the like button. Every like tells YouTube to share it with more people. Hit subscribe and turn on notifications. We rescue forgotten stories from dusty archives daily. Stories about engineers who saved lives with brass washers and brilliant thinking. Real people, real heroism. Drop a comment now and tell us where you're watching from. Texas, Germany, United States, Japan? Our community spans the globe. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if someone in your family served. Just let us know you're here. Thank you for watching, and thank you for making sure Beatrice Schilling doesn't disappear into silence. She deserves to be remembered, and you're helping make that happen.